Hello everybody, this is Ramesh Pani. In this video, we can talk about complex number. To add the complex number a plus bi with c plus di, we have to add the real part a with the real part c and imaginary part bi with the imaginary part di. So we have a plus c plus b plus d times I. To subtract the complex number c plus di from a plus bi, we have to subtract the real part c from the real part a, the imaginary part di from the imaginary part bi. So we have a minus c plus b minus d times I. 2 plus 3i plus minus 3 plus 2i. Here the real part is 2 and minus 3. So 2 minus 3 plus the imaginary part is 3i and 2i. So we have 3 plus 2i. So we have 2 minus 3 equal to minus 1 and 3 plus 2 times I equal to 5i. So we have 2 plus 3i plus minus 3 plus 2i equal to minus 1 plus 5i. 5i minus of 1 minus I, 5i, by using the distributive property, minus times 1 is minus 1, minus times minus is plus I. Now there is only one real part, so you have to write minus 1. So there are two imaginary parts here, 5i and I. So add them. So we have 5 plus 1 times I. So we have minus 1 plus 5 plus 1 is 6i. Multiplication of complex numbers. Let us multiply the complex number 3i times 2 minus I using the distributive property. 3i times 2 minus 3i times I. 3 times 2 is 6i. 3 I times I, 3i square. So 6i minus 3, replace I square with minus 1. So we have 3 times minus 1, which equals 6i minus times minus plus 3. So we have 3 plus 6i. Let us see some other example. 2 minus 5i times 4 plus I using the FOIL method. 2 times 4 plus 2 times I minus 5I times 4 minus times plus is minus 5I times I. So we have 2 times 4 is 8, 2 times I is 2I, 5 times 4 is 20 times I minus 5, I times I is I squared. So we have 8 minus 20I plus 2I minus 18I. Now replace I square with minus 1. So we have minus 5 times minus 1, which equals 8 minus 18I minus times minus is plus 5. Now adding the real parts 8 and 5, we have 13 minus 18I. Let us see some other example. 2 minus I all square equal to 2 minus I times 2 minus I. By using the FOIL method, we have 2 times 2 minus 2 times I minus I times 2 and I times I. So we have 2 times 2 is 4 minus 2I minus 2I. They are the imaginary part, so we add them. So we have minus 4I, I square equal to minus 1. So replace I square with minus 1. So here the two real parts 4 and minus 1, subtract them. So we have 3 minus 4I. The complex number a plus bi and a minus bi are called complex conjugates. So product of the complex conjugates a plus bi times a minus bi equal to a square plus b square. When you multiply two complex conjugates, the imaginary unity will not be there in their product. See here, the imaginary unit is there, I. Here also imaginary unit is there, I. So when you multiply these two, we get a square plus b square. There is no imaginary unit, only the real part. So whenever we divide a complex number, you have to multiply the complex conjugates of the denominator and multiply the conjugate with the numerator and denominator, so that we can eliminate the imaginary parts and can be write in the form of a plus bi. Let us divide 2 plus I over 1 minus I. 1 minus I is a complex number. To multiply the complex conjugate, we have to find the complex conjugate of 1 minus I is 1 plus I. So multiply both with the numerator and with the denominator 1 plus I, because 1 plus I is the complex conjugate of 1 minus I. So we have, by using the FOIL method, we have 2 times 1 plus 2 times I times 1 plus I times I square, over using this A plus BI times A minus BI, the sum and difference of the two numbers equal to A square plus B square. So we have 1 minus I and 1 plus I, sum and difference of two numbers 1 and I. So we have 1 square minus I square. Simplifying this, we have 2 times 1 is 2, 2I plus 1I equal to 3I, and replacing I square with minus 1, we have minus 1 here, over 1 square is 1, and replacing I square with minus 1, so minus 1 times minus is plus 1. So simplifying this, we have 1, 2 minus 1 is 1 plus 3I over 1 plus 1 is 2. So we can write this in the form of A plus BI. So 1 over 2 plus 3I over 2, which is in the form of A plus BI.